off track. And as people continue to join us, we'll just kind of get started here. So we went over inheritance patterns with the prototype, using constructors and prototypes and stuff like this. The class keyword makes this much easier. So let's look at our example from earlier, and let us explore ways. Let's see, where was it? It was in file, open, derp. Okay, and it was under this inheritance examples. Okay, so we built a fruit constructor, and we built two other constructors, and as we built these other constructors, we extended the attributes that came from the fruit constructor to whatever gets called with the new keyword when we call these child constructors, right? The child objects that inherit from the parent object, which will be the prototype that's on fruit. Okay, so if we were to take this exact example, let me. I may have to split screen and just bump it down a little bit. Is that okay? Still for everybody? Can you guys still see pretty well? It's not your fault for derailing us, I promise. I can do a better job. Okay, so you guys can still see pretty good. Okay, so let's talk about what we can do to turn this into a class. And so some of you may have already figured this out because it's pretty intuitive as soon as you get the idea of the pattern. You're going to recognize a pattern here. So remember, this is a constructor function, and so when we call the new keyword, some cool stuff happens under the hood with it. So we get this class keyword now that we can build our fruit objects out of, okay? So the class is just going to behave just like that constructor keyword, or just like that constructor function. However, the one difference is you have to define your initial values you want stored on the class with your constructor, okay? So if I was to create a fruit object or constructor class, I would pass in my attributes for my fruit, so just like here, and we're just going to say the same exact type of stuff. So it really is just that simple. You can paste your same code like right over. Now, what's cool about this is we don't necessarily need to change anything on the prototype. We can build methods right here within the class, and they will exist on that prototype. Okay. Let's take a look at what this does. Let's just say we had a method that was like, foo, okay? And foo essentially just console.log, foo, cool. So now let's create a new object, const my fruit, and then we're just gonna supply it with a few, equals new fruit, and supply it with just some. Okay, there we go. Supply it with a few attributes here. We're just going to do one class. We're not going to extend it yet. We're going to just keep it like chill. Okay, console.log fruit, my fruit. Whoops, it's not a function. And let's pull up the Quokka experience. So check it out. We have a fruit. Look at just the same exact way that we had it, where like if we were to do this with like that user constructor that we did earlier, this is saying, hey, we got an object that came from the fruit family line. So let's look at this in the console and let's check out the prototype, and let's double check to make sure that everything is the way that we intend it to be. Okay, we got a fruit. My fruit is a fruit. And look, we got this prototype, and check it out. We got foo assigned to the prototype and not to the constructor, okay? Not to the property on the object. It's on the prototype. So you see how much easier that is? We went from doing something like this, right, to something like this. So the issue, or the idea here is that the objects that you're going to create, the properties that you want set on those objects will be defined in your constructor on your class. Constructor is a method that comes with the class keyword, okay? You call constructor, or constructor will get called during the creation of this object. And it's going to happen pretty much the same way that I described to you earlier. That's why this is so much easier to teach after you understand the prototype. Okay? Now, this is going to come in handy for you next week, when on Monday you are tasked with the daunting task of learning all about data structures and algorithms. Because every data structure that we have you build next week, which there are about 8 or 9 of them, 9 being a stretch problem, every data structure we have you build next week is going to be built using the class keyword, the class syntax. So this class keyword comes with CS6. So now, by the time you depart our doors of Lambda School and go out into the real world, you'll be able to describe to anybody who's been using the class keyword for the last couple of years how it works under the hood. And I'm assuming and hoping that by the end of at least next week, you would already be able to do so, which I can almost guarantee you don't get a chance to learn this stuff in JavaScript in almost any other environment. This is something that we're teaching you because it's super prevalent, and it's very common use pattern of object delegation, creation, instantiation, everything. And people are using classes all the time without understanding how they operate. And now you are the experts in the field. You get to go out there, well, eventually you will go out there and you will say, hey, I understand the object prototypal inheritance pattern in JavaScript. And because of that, I can build objects. But we're not quite there yet. So you've been able to see this firsthand right away. Let's do this in such a way that makes sense. So we had that shipped method. Let's build that shipped method on here. So on our fruit object, we're going to say shipped. And shipped is just going to tell us that the same thing. In fact, we could take this snippet and say, here we go. Oh, I didn't call, let me call real quick my fruit.foo and see what happens, okay? So if I change this to shipped, okay, so we got our method, it's getting called the same way that we would expect it to, and then we're gonna take some sort of destination, right, from shipped. That's what we did right here. We get just such a nicer syntax. It's so much cleaner, and you don't even have to worry about the function keyword in here. It's just oh, this is a method on an object, on a prototype object. We're good to go. We know what to do with it. Yeah, when you use class, you do not need to use the prototype keyword anymore. You don't need to reference it anymore. You're building it down here in the class itself, okay? And so if I say in this, instead of the shipped pool, whatever it was saying, I'm going to say shipping this dot name to our destination. Cool. So now I need to give this a destination, right? I need to tell this where to go because I don't have it defined. Okay. Once again, this is just a function. We're passing in a parameter. The parameter is going to be set when we call it. Right now, the parameter is nothing, right? So I have to tell it where we want it to go. Where do we want to ship this fruit? Let's ship it all the way out from Hawaii. If it's a banana, it's probably Florida, right? So let's ship it all the way from Florida to California. They probably have banana plantations elsewhere, but closer than Florida. But yeah, we're shipping our banana to California. Check it out. So yeah, a lot of them come from South America, Florida. By the way, bananas in South America, just not the same as bananas you can get in the U.S. I lived in Brazil, and man, the bananas down there were just world class. They just taste totally different. They're just like a real banana. Anyway, okay, neither here nor there. So now we can do all this stuff. So I can say, oh, calculate calories. Okay, so that's a function that we want to recreate. And remember, it's going to live on our prototype, so we're building it outside of the constructor. Okay, so it's built in the class block. Sorry, if you look at these braces. So if you look at these braces, I'm building it within the class block, but outside of the constructor block. Okay, constructor will be the properties that get inherited on the object when we call new, but what gets held here gets built onto the prototype. So this we want to say our same logic from down here. We're going to say calories in the bananas, and I've got to say bananas. are this dot calories times 200. So if I were to call that, let's do this now and call, actually I don't even need a console log because it's not, we're console logging once already. So give me a second. Whoa, why did that happen? Oh my gosh. There we go. Sometimes, yeah, calculate, cals. Awesome. Calories in bananas are 20. We got 20 calories per banana. Okay. So a pretty fun little exercise here in, you know, and then let's log this again in the console. In the, where's my Chrome browser? There it is. I can do a hard refresh so we get rid of the syntax there. Okay, now I can say my fruits. Okay, so I can do that again. If I can press up properly. Okay, and then look. So once again, only 4 properties were created, but we have 2 methods on the prototype. So whose prototype, in this case, whose prototype, or what is the prototype of my fruit? Or what does my fruit prototype, oh my gosh, what am I trying to say? What prototype does my fruit point to? Who does it belong to? Fruit. Fruit will get, when we call it with the new keyword, fruit is just sort of a boilerplate object or an object creator. Okay, and it has a prototype that we can use, which if you're looking at proto is the way you can access that. But remember, once again, there's some intricacies there that you do not want to, I mean, it's definitely good for you to go and look up why you should not access the underscore proto object directly. It's just, there is no traditional way to like just access it. That's why browsers have created this thing. And if you look, if you can kind of slightly see, and it might not do great with the recording, right here in Chrome's DevTools, you can open it up just by right-clicking, inspect, and then go to console so you can play around with JavaScript. This is going to be a darker hue on this text, and this is a lighter hue, indicating one thing, that this comes from Chrome, and it does not actually exist in the JavaScript language, okay? It's not native to JavaScript. It came from Chrome, okay? Ah, yes. How can you refer to those? Well, you use patterns like the way we did earlier. So if you want to refer to those other objects in your buildings, and we're going to get into some inheritance still, like right away. So I'm gonna take this now, and we're actually going to build our pineapple object and our banana, or not pineapple, sorry, our banana, and what do we do? Kiwi. That's what we did earlier. So we're going to build our child objects, and you're going to see how these child objects can extend and use those prototypes. And this is how you would do that. You'd want to refer to the methods in regards to other objects by extending the parent class, which is what we're going to do right now. So you take this, and let's say that we have satisfied the requirements of our parent fruit class. Okay, it's our giant template, okay? And it is going to take care of the idea that we can delegate down these properties that are on the constructor and then these methods that are actually on the prototype to our child objects, okay? So we're going to extend class fruit. And the way that looks is class, what did we call it? Banana extends, this is a keyword in JavaScript, fruit. And then you go about doing the same thing. Okay? Now this is what's really important, okay? And here's where the gotchas and the catches are going to happen. Okay? Remember how we had to do fruit.call right here when we built our banana constructor? No longer do we have to do that. We're extending fruit, but in order to pass any attributes that we want to be specific to banana up through the prototype chain or up through the constructor of the parent, what we need to do is say constructor, okay, just like we would, because we're building an object, so we need the constructor in there, okay? So constructor gets some sort of like unique attributes. So we called these banana adders, right? And what's another attribute of a banana? We can put, because I didn't like do monkeys. I guess we can just do that same thing. Okay. Instead of calling here fruit.call, we call another method. And who knows what that method is? Just out of curiosity. I'm curious to see who's leaning forward. Super duper, right? So we call super and we pass it those same attributes that come in. So those attributes would be the banana attributes. Guys, this is the same thing in a lot of respects as doing fruit.call with this keyword and then our attributes that we wanted. So that would be banana attributes. Okay, no longer do we have to do that. Banana attributes come in. They get set up in a new way. We're extending fruit. So just by the extending nature, just by calling extends, in our constructor, you have to actually extend back or super back the properties that come into your constructor function here. Okay, that's the rule of thumb. It's brand new syntax. It looks weird. It's kind of crazy, and this behaves a little bit differently than maybe you're already used to. Just know that it is. It's actually probably doing exactly what you're used to it doing. Right? It's a child class, so this is great. Now I can set on this constructor our this.doMonkeys. Let's just take it from here. Do monkeys like it equals banana attributes, do monkeys like it. Okay. And then what did we have? We had a couple of functions. Oh, and look, do we have to do object.create fruit prototype and assign it to the bananas prototype anymore? The answer to that is no, we don't. But because if we want to do this, we can go check who likes it, which is our crazy. I'm just going to keep the examples straightforward and straight across the board because I don't want to get into any confusion or anything like special or new. We're going to do the same exact logic that we had. Okay, it's kind of a contrived example, but we are used to it already. We're used to Ryan coming up with weird examples. Okay, so now let us build our banana. Look at that. And check out what lives. I was actually, oh no, that's a property, duh, because that came out of, yeah, so that's the property. I would have been shocked if I saw what I was getting shocked at if I saw this method. Okay, but let's look at this in the console now. Okay, and then what I'm gonna do is actually pull open Python tutor, and so we can get a sense of what's going on. Ooh, fruit has already been declared. Got to do a hard refresh. Okay, banana. Okay, look at it. So we inherited. We got a new property that came straight from banana, and this is the banana class now. So all this stuff belongs to banana. But check out our prototype. So our prototype has a check who likes it on it. We don't see anything more than that. Let's see. Maybe yeah. Okay. Now this is where the kicker comes in. We have our. See, can we get farther? Shipped and calculates calories. Boom, there it is. So it's a little bit nested and a little bit contrived to sort of dive into it this way through, because there's a lot of things that are sort of muddying up the waters here. But the important thing to note is that right here, we gained access to our shipped and calculate calories methods. And if you want me to prove that those exist, I can simply call my bananas dot shipped. My bananas dot is not defined. What is it that we called it? New bananas, sorry. And pass it a destination. Let's send these bananas up to British Columbia. How, yeah, give just like emojis. I need to see your emoticons. Throw them out there in the Slack channel. How are we feeling about this? Did we get excited? Is this scary? Is this scream face? Is it fast parrot? Is it slow parrot that goes to fast parrot? This is the lambda. I want to call that like the disco lambda, like potato, fast parrot, coffee parrot. Nice. What's funny about the banana paradigm? I'm glad you guys brought. I'm glad you guys chose bananas and kiwis as our fruit today. Well, because bananas was the name of the language that our CS1 students built. Yeah, you guys at Lambda School, you got to write a new language. So they called it banana script. Basically, it's like transpiled or compiled JavaScript. It's pretty cool. Parrots eat bananas too, right? I've seen it. I'm sure there's a fancy YouTube video of a parrot eating banana somewhere. Okay, so the kicker was here. We call new bananas. We check out what's on the banana. What's on its prototype is just this check who likes it. Okay, so right here, this is once again the kicker. Okay, I'm gonna get my annotator. I don't like red. There it is, parrot eats banana, boom. Okay, so here it is, our very own, and it's pointing at fruit, but check it out. Check out what it really is. I mean, the underscores for proto is like, hey, this is a prototype of fruit, but look, we built our very own prototype. Do you see in this prototype, in this object that I just opened up, do you see the shipped or the, what did we call them? Calculate calories methods anywhere on this? Are they exist? Do they exist? If you look right here, what exists is the check who likes it. And the checks who likes it method belongs to who? Belongs to what object? Banana. Okay. This is beautiful stuff. Gets super eloquent, and you're gonna see it all happen in just a second. So now let's continue with our kiwi, Senor Kiwi. We're gonna say class kiwi extends fruit as well. And I think you could even extend banana if you wanted to. But we're going to just keep these as sibling objects. Some sort of props come in, properties, right? And this one, we're going to super back those properties. And on this one, we're going to say this dot, what do we call the kiwi? Kiwi is fuzzy. Nice. Equals props dot is fuzzy. Constructor, we're just going to check if fuzzy. If this dot fuzzy, then dang, kiwi, you're fuzzy. Oh, and then we can call, oh yeah, we're going to be able to get through that in just a second, that piece. But then it's a tree, this is a fuzzy fruit, it's a kiwi. It's definitely ripe. We got to get these shipped right away. And then we would say something to the effect of new, oh yeah. Okay. I can calculate the calories of the kiwi. And then you'll see that they will log out. Calories in kiwis are 20. We could make that English a little better. And then I can also ship our kiwis somewhere. Shipped out to Los Angeles. Shipping kiwis to Los Angeles. Okay. And then we had our little Swaparooski. So I don't need that that forward breaking slash to break the line because I'm using backticks. Another really good reason to use backticks when you're crafting lines like this. And then we're going to call check if fuzzy on our banana or on our kiwi. Don't need this anymore. Let's see. Thank you. Dang kiwi, you fuzzy. Cool. Thanks, Troy. You the man. Okay, cool. So now, what if I wanted to do our own Swaparooski again? And I was like, hey, I want to check to see if so I know that bananas is an object that monkeys like. So I'm going to check to see if monkeys like kiwis as well. So I can call that new bananas dot check who likes it, and then I'm going to bind that, or I'm going to call it with new kiwi. Monkeys hate kiwis. The behavior is exactly the same. You guys are very familiar with this now. Well, at least you've learned about it for a couple hours today. Okay? So look at this. We've done some overkill here. As far as like, you know, I could delete some spaces and clean this up and tighten up my code a little bit. Okay? But we have now 57 lines of code, give or take spaces. And then give or take spaces, it was almost double. 108 lines of code. How cool is that? And we have the same exact functionality as before. If I take this and I run these same methods, and these two and I run these same methods. Oh, I also give or take some spaces. So it's not quite double, but yeah, you guys get the point. Okay. So give or take some, you know, so a few like methods and like lines of code, like we are achieving the same thing. Monkeys love bananas. All of our code works. All of it's bound and tightened up together. And we are creating multiple objects from the same parent. I think there's one more method that we had. Let's see what it was. No, we had check who likes it. We've got couple others. Calculate cows, shift, calculate cows. So how great is this? This is how you build large-scale applications in JavaScript these days. If you were to do this, and you guys actually get a chance to do this with some DOM manipulation. Ivan has been like the last couple of months, and you guys will meet Ivan next week. He's been building out curriculum for your DOM manipulation sprints, and so you learn about HTML, CSS, like in depth, like really cool stuff. And then he takes you through like the DOM and how you can manipulate the DOM, and you use this stuff. Right, so you get a chance to work with it for the next 2 weeks after this. So this is not going to be foreign to you. And then you get a chance to work with it for like pretty much the rest of the web portion of the curriculum because you're using classes. Anytime we do front-end code with React, we're using classes everywhere. Okay? All right, gang. Let us... there is a mini project. I know that some of you are finished. In fact, can I get a poll? how finished you are with the JavaScript 2 project. And then I'm just going to paste this in Slack on a 1 to 5. 1 being you maybe only have a couple of methods written, or you're only passing a couple of the tests, or things like that. And then 5 being you're completely done, including like stretch problems like the CheckMatchingLeaves algorithm. And then a 4 would be like you're done with everything except for maybe CheckMatchingLeaves. Okay, a lot of people stuck on CheckMatchingLeaves. Okay, what I'm going to do, as these votes come in, I have a feeling of exactly what I want to do. Okay, this is it. If you are still working, okay, if you haven't finished the class.js file, go ahead and break out with your partners and do that now, between now and the end of the day. And then if you have finished everything except for CheckMatchingLeaves, I'm going to pseudo code out how to build CheckMatchingLeaves, and then tomorrow we'll give you like a full solution to it. So that way you'll have seen pretty much a solution to everything in this entire module. Okay. And then, yeah, once again, if you're not up to finishing like if you haven't finished prototypes and the classes and everything, then go ahead and break out and start working on those. Otherwise, and then you'll get a video, like I'll do this pseudocode in the next 5-10 minutes, and I'll record it so that those who are still working on it, those who get there, that you guys can have a recording of the pseudocode. Okay. So here, let me open up. In fact, what I'll do, no, I can do this. Okay, so JavaScript 2, There we go. All right, recursion. By the way, MPJ in his recursion video makes fun of anyone who tries to teach you with N Fibonacci. In fact, his instruction to you watching that video is to murder me. But I have been asked this 5 times in a JavaScript interview situation. No, I'd say 4 times. Cool. Oh, I don't think that's the code that they're wondering about. Yeah, that's the, okay, so that's the inheritance patterns gist. I will take this and I will get the class.js pushed up right now. Not that. Get out of here. Come on. Come on, man. Get with the times, right? Normally I do this from the command line, but sometimes I like GUIs. They're easy. And class examples. Yeah. Publishing secret gist. Publishing secret gist. Class conversion. That's what I'm going to call it. Secret gist created. And it's also, these links are all up in Piazza. So I will put this one in Piazza right meow. If you look at the resources in JavaScript 2 materials, I'm posting the resources on object creation and inheritance, and the class example is getting saved as a gist in that link right now. Cool. And then I have your video from earlier saved there already. So the object creation and prototypal inheritance video is up there as well. Okay. So let's look at the pseudocode for recursion for CheckMatchingLeaves. All right. I love how easy classes are, man. It's so nice because like we went through, it took us an hour and a half to like get through all of that prototypal inheritance stuff earlier this morning with a few like, sidebar, like little mini lessons and stuff. And then it was just like, boom, 25 minutes, 30 minutes, we're done talking about classes. Like you already knew it. So you have to learn both. Okay. All right. Extra credit. I don't like the term extra credit, so ignore that. This should be something like stretch algorithm. It's going to stretch you. going to push you until you break down bawling like a baby. Okay, so for this algorithm, it's very much like flatten, right? Except that we're not trying to flatten out the object. What we're trying to do is we're trying to look at a couple of objects, okay? And then let's say we have an A of 1, B 1, C has an object as a property where C1 is 1, okay? C2 is also a nested object, okay, where its property is C, what do I want to call this, CA1? Cool, that's great, and then 1. What we need to do, why? It's not liking this, okay, what we need to do, jeez Louise, come on. Tree. Essentially, this looks just like a tree, right? And where do you see a tree that looks like this all the time? Well, you see it in HTML, right? If this was an HTML document, I could go HTML, right? Now I have these like snippets, and I could say, in this HTML document, I could say I have a head tag, not headers. It's giving my JavaScript syntax for me. And then the head tag, I could put like a bunch of meta tags, not meta, nice, meta, and then that's meta. And then I could put like a title tag, right? Cool. Okay, what does this look like to you? Does it not look very similar to this? Let's say that I had, okay, so tree would be the HTML tag, and then I had head, and then I had a body, Dobby, is that you, Dobby? And then I had some script tags, right? It's just a tree. The DOM HTML code, it's just an object. It's just a tree object, okay? So that's sort of what this looks like. And if you were to traverse a DOM tree, a tree of nodes, all those little like tags that we saw, you can think of these as individual nodes. Like HTML is a node, head's a node, right? This is a node, okay? It's an element that exists on a tree, a thing, okay? So that's similar to the way you can conceptualize this tree. It's nothing to be scared about. We use trees all the time, okay? But our algorithm is going to go through this tree because we have something that our algorithm needs to do for us. Our algorithm needs to check the leaves on this tree. And the leaf would be the value that's found at each individual node. So picture this key value pair as individual nodes, okay? So this C key value pair is another object, and the C1, and then C2, and then C1, and so on and so forth. Now, your goal with check matching leaves is to distinguish if all of these leaves on this tree are the same thing. Does 1 triple equals 1? That's your algorithm, okay? And how you're going to achieve this is through some magnificent coding, through some really deep level understanding of recursion, okay? So one of the best ways that people do this is they will have some sort of value to compare against, okay? So the first step of your algorithm would be to initialize some value, okay? So some variable, initialize a variable that you can use to find the value at those nodes, okay? So you're going to use this variable to say, if what is found at this branch or at this tree is not an object, we're gonna check it against our variable, okay? So you can initialize some variable, and then what you're truly gonna return out of this is whether or not all of those things match. So and then you're gonna initialize some flag. So it's a Boolean, okay? So some Boolean flag that you're going to trick or you're going to trip up if you find a value that is not the same as the original value, Okay, so let's go back to, let me grab from the test so you can see exactly what we're testing with. You grab this recursion file and go to my trees. Okay, they did a better job at naming their branches on their trees. Okay, so if every single, this is your principle, okay? If every single one of these values, right, is the same, then we return our flag. So our flag right here, return true or false. That's what this is expecting. It's expecting that this input right here would actually return false, but you need to be able to check every single leaf on the tree. You need to be able to check every single value that's assigned to a property. Okay, property being what? X, Y, and Z are properties. XA is a property. XX, X, and then value being what? The number 1. Because if I passed this object here, the second object, it's going to fail. So you're going to, but it's only going to fail at the very most nested element, which is cruel and unusual punishment for a JavaScript learner. Okay. It's cruel and unusual punishment because it's the most nested element. So you have to make sure that your recursive algorithm can drill all the way down to all of these steps. Alrighty? So let's move into the rest of our pseudocode. Okay, so how are you going to achieve this recursively? Well, a lot of people actually initialize some helper function. And that's going to be like your leaf checker. Okay? Now, this is going to be a recursive function. All right, now you're going to receive an object in your CheckMatchingLeaves algorithm, so you can assume that you can just pass that object and pass obj. Okay? So inside of our recursive algorithm, we are going to, our recursive function, we're going to do a couple of checks. I don't want to give away everything, so I'm not going to tell you exactly what you're checking over, but you need to essentially check all the keys. Okay? So there's a hint right there. This is a hint. Check all the keys. If a key is an object, you know, or we haven't set value to anything yet. So value is not defined yet. Okay? If our key is an object and value is not defined, and you can do this with the and principle. So you can check two things in one conditional. So that looks like if, so const name equals Ryan, and const age equals 31. And I can say if name triple equals Ryan, and age is greater than 30, console.log, party on. Quokka. Party on, Wayne. Two conditions in one statement. And you can say if both of these things are true, so if name matches Ryan explicitly, 3 triple equals, and age is greater than 30, then we're going to party on, Garth. Right? Okay. All right, so that's that condition. I'm going to leave these indented when I paste you this pseudocode in Slack. Okay, so that is, okay, so if key is an object and our value is not defined or is undefined, then what do we need to do? Well, we need to assign value, okay? And then you can break out of this by simply just doing something like, I don't know, return undefined or something, or you can potentially just return something like null. I don't know. you can figure it out. So we're done and like we're good, then we can move on to the next iteration. Because remember, this is check all the keys. This is hint, a for loop of some kind. Okay. So we're looping. We're checking. If that value is undefined and this key is an object, okay, then we need to assign the value and we need to break back to the next iteration in the for loop. Otherwise, we're going to check if simply our first condition, this first one that we want, we're going to check to see if the value found, so now it's not the key anymore, so if a value is found at that key, okay, that is an object, then we need to recurse. And then the last condition would be if a value is found and it does not match our initial value, okay, then we trip our flag to false and return out of the loop. That's where the recursion is going to happen. And you're going to do this, most commonly it's done with like a nested function inside. Don't do that. There we go. Which line are you referring to, Vartan? Are you saying yeah, so that's your initial value. Your initial value is going to be set the first time you find a value at a key that does not, so that's right here. Well, the initial check will be if this thing is not defined, right? So if our key is an object, right, that we're looking at, so if our key is an object itself, and what we're looking at is a value that is undefined, then we need to assign the value. Sorry. If our initial value, I should have said. Okay, that's the kicker there. I wasn't actually meaning a value of a key value pair on the tree. This is the initial value that you've initialized. You can initialize, just initialize it to undefined. So it's the first time you pass through your iteration. So it's like if this thing does not exist, right, and this is an object, then we're going to assign the value and then return out of that particular space. Otherwise, if the value is an object, we need to pass it back up to our function. So if this value is an object, we're going to take value and we're going to feed it up through our function. So let me give you this again. Let me just edit this message. Okay. Awesome. All right. Please have fun with this algorithm because it is a blast. And it will help you in the future. Hint, hint, next week. Kind of understand ways that you can use recursion to check for things breadth or depth first, search-wise. Cool. All right, guys, have a wonderful evening. The rest of the evening, if you get finished with CheckMatchingLeaves and you're all done, I do have another assignment that will be, there's some of its carryover, and it's called nice. It's called Advanced JavaScript. So if you've already done that, then we can get you peeking forward at the data structures materials, and then you can just review and make sure all of your stuff is cleaned up and submitted for the week, and make sure that you're really well prepared for the fun little no pressure sprint challenge tomorrow. Okay, so it's going to be an awesome day tomorrow morning. You don't have a code challenge on Replit. I will release a sprint challenge for you in the morning. So No, it's no pressure. It even says it in the README. So the only pressure that you should be feeling here at Lambda School is the ability to get better every day. And that is relative to where you were when you started. Does that sound like a fair enough principle? We're going to ensure that you learn the things you need to learn and study the things you need to study. So just remember, the only pressure you ever need to feel here at Lambda School is the pressure to do better than you did yesterday. Oh, and I also wanted to show you guys under the hood. I'm going to stop this recording, stop sharing.